on day 2 of PO6, writing and solving equations in real context. I warned you yesterday, opposite operations is going to be the method to use. I showed you what I like to call the Bowser equations, the linear equations with variables on both sides, multiple steps, parentheses, all that sort of stuff. We're working our way up to it. We started yesterday with kind of a review of two-step equations, and we are going to skip ahead. No, we're not going to skip ahead. We're going to talk about how to handle word problems also. So I think, let's see, this one, yeah, PO7. Okay, so in a word problem, okay, especially a two-step equation, you're looking for three kind of parts. You've got your variable, you got your coefficient, and you've got the constant. Okay, we've defined variables before. What is a variable? Yeah. The unknown, not necessarily when you're solving for a variable, it ends up being the answer, but a variable is an unknown. And usually we use a letter to describe that. N is very common, X, Y, all very common. Really you can use whatever letter that you want to, but it's an unknown value and it's usually the letter. Yes?
For a variable, can I draw a detailed picture of my chocolate milk carton?
Why would you do that?
I don't know, can I?
No. Coefficients. Coefficients. What is it? What does it do?
Would it be wrong if I throw?
Yes, I will say yes. Any milk cartons are wrong. Coefficient is the number before a variable. And what it does is it tells you how many of the variable you have. Okay, tell you how many of the variable you have. That's its main function. Okay, it's that number before a variable and tells you how many of the variable you have. We saw this yesterday, and I don't remember if this was an exact example or not, but if you had something like this, 8n equals 24, what this tells us is that whatever n is, we have 8 of them. And 8 of those n's make 24. That's why we divide by 8, because we want to know what one n is, and that's ultimately how we solve the equation, right? So that coefficient 8 tells us how many n's we have. If 8 of them make 24, ultimately our goal is to figure out what one of them equals. Okay? And then the constants. The constants. Anyone know what the constant is? Yeah.
It's like a number that's independent.
A number without a variable. Independence is a better way to say it, but I'm going to kind of relate it to the variable. A number without a variable. It's usually tells you where you start. What's already happened. Where you start, what's already happened, what doesn't change. There's a lot of different ways to describe a constant. You could also say it's constantly alone, just like I was in high school on Saturday nights.
Okay.
Okay? But a number without a variable, it's where something starts, it's what's already happened, it's what doesn't change. Okay? All those things are fine. So, you signed up to help a charity with preserving the rainforest. How noble of you. They ask for $20 up front, and then you'll give $2 per month after that. Write the equation. How much money will you have given after 6 months, 8 months, and 2 years? So we're going to kind of start by identifying what is our variable. What is our, I better write it out because coefficient and constants start with the same letter. What is our variable? What is our coefficient? And what is our constant? Okay, so the variable, Peyton said before, it's the answer. It's kind of what we're solving for, right? Or it's what changes. What's changing here? If the question is how much money will you give it after 6 months, how about 8 months, after 2 years, what's being changed? Henry?
The months.
The months, okay? The time, but it's in units of months, and so we'll use M for that. In our equation, we'll use M. Okay? Now the coefficient, I'm kind of already breaking what I said here, but because we're talking about in context of something here. But there are certain words, just like in CO4, we talked about sum, difference, product, right? There are certain words that can help you identify the coefficient. Anyone know what those words are? Since a coefficient is attached to the variable, words like per or each or every are big hints you're dealing with a coefficient. So what would the coefficient be up here, Grace? Not word, but what would the number be? 2, right? $2 per month. Okay, that word per can help you identify where the coefficient is. So the coefficient is 2, and that refers to the dollars. And then the constant, where we start, what's already happened, what doesn't change. Jude?
The $20.
The 20 bucks, right? You give that right away, that doesn't change. Whether you're giving to this charity for a year or 10 years or the rest of your life, that $20 that you gave up front is a set flat fee, it doesn't change. So putting all this together, the total amount of money that you are giving to this charity is going to be $2 per month plus the original 20 that you gave. Does everyone see how we got that?
Yes.
Okay. Lucas.
When we're solving these, do we have to show our work, or can we just write the equation and the answers to the questions?
Homework, work required.
Like, do we have to do
Test, no work
Do
required.
we have to do variable calling, coefficient calling?
For starting on this one, yes, we are. Okay. Rowan.
Is this charity tax deductible?
Yes.
Hooray.
Yes, it is.
It's basically free.
So now, to solve the rest of this, we can use a function table. We can do the value for M, and then the output, how much money we are going to be giving to the charity here. I'll make actually a third column because we'll do this the right way the first time. We'll do it maximum work allowed, because why not? Okay. So our function table here, we have the variable, what we're plugging in, we have the equation, and we have the output, right? Input, equation, output. So the first question says, how much money will you give after 6 months? What am I doing with that 6? What am I doing with that 6? Will? Plugging it in for M. So this becomes 2 times 6 plus 20, which is 26. Nope, that's wrong. Whoopsie-doo. Whoopsie-doo, I made a mistake. That's just part of what makes math great. We learn and we grow, and so can you when you say whoopsie-doo. You gotta wait for the twist. We'll try that again. Whoopsie-doo, I made a mistake. That's just part of what makes math great. We learn and we grow, and so can you when you say no, you wait for the twist. I'm not going to do this if you don't do it right. I'm doing my part. You wait for the twist, and then whoopsie-doo. We'll try it one more time. Whoopsie-doo, I made a mistake. That's just part of what makes math great. We learn and we grow, and so can you when you say whoopsie-doo. That's better. Thank you. Okay. Goodness. Now I'm all sweaty on picture day. Thanks for that. All right. Then it says after 8 months. So now our variable is 8, which means what are we doing with that 8? Putting it into the equation. So 2 times 8 plus 20. I don't dare try to solve this mentally. Someone else with quick math. Yeah. What?
36.
Okay. $36. Right? But now I throw you a little bit of a curveball, maybe, sort of. But the last one here is 2 years.
It's just.
Am I plugging in 2 for M here?
No.
No, I'm plugging in what?
24.
Right? Because if our unit is in months, 2 years is 24 months. So we have 2 times 24,
68.
which is 48 plus 20, we get 68. Okay? So this is the process that you're going to be using here for solving these equations. Questions on any of this? Not yet, sir. We are not yet finished with the lesson. Okay, next one. Anyone still need a copy down notes? Okay.
You're in the next one.
Schultz has 3,039,001 hairs on his head, and each day he loses 60 of them. Write the equation. How many hairs we have left after 120 days?
Mr. Schultz, that kind of sounds. You'd be pretty old.
3, 2, 1, you are quiet. 1,580 days and 50,650 days. So, again, we're going to start with our variable, our coefficients, and our constants. Variable, what is changing?
Your hair. Face.
So the hair is ultimately the solution to the equation, but what's changing within the equation?
Is it days?
Days,
I
right?
was gonna say, you said Schultz, not Schultz.
Correct. Yes, thank you. Thank you.
you.
Okay, so it's very common in context for variables to be time, because time is something that, you know, constantly changes. You can also look and see, like, you know, what am I asking for? Days, days, days. What's changing, what I'm giving you, right? That's going to be your variable most of the time. How about coefficient here? Look for those secret words that could be helpful. Christian?
3 million, what?
So that would mean that I'm losing 3,039,001 hairs each day. If we're attaching the coefficient.
60.
It doesn't work when 31 people all yell out at once. It just doesn't. Okay? Blakely. Not 60. You're on the right track, but it's not 60. If I'm losing the hair, Grace, negative 60. Okay? If the total number of hairs, if that constant is decreasing, the coefficient is going to be negative. Okay? Again, why word problems can be a little bit tricky. You have to interpret the language being used here. So negative 60 for the coefficient. And the constants, what I start with, what doesn't, well, this ultimately changes based on the final answer, but where I start, okay, what's already happened, that's the 3,039,001. So, put all of this together, what is the equation?
You'd be pretty old if you were.
Shh. You'd make me pretty happy if you raise your hand. Henry.
Negative 60 times the number of days, and then the total divided by that.
Okay, so the hairs on my head is equal to negative 60 times d. Did you say divided by? Is that you said it right?
Subtract.
Well, I don't start with negative 3,039,000. This one might make more sense to put that constant first. If I'm starting with 3,039,001, I'm subtracting, I'm taking away 60 hairs per day. Okay? If you wrote the negative 60d first, you'd then put plus 3,039,000, because remember that the operation belongs to the number. I am starting with a positive number of hairs on my head. Right? Now, with our table, here's our equation, right? With our table, we have the day, we have the equation, 3,039,001 minus 60 times d, and we have the answer, the hairs. So just like we did before, first after 120 days, so 3,039,001 minus 60 times 120. Someone with the quick maths, how many hairs do I have left after 2 months' time? 4 months' time? Henry?
3,000,
Hopefully more than that.
No, it's
no, about 3,000. 3,025,000.
25,000. And 9. Shoot.
I can't.
What comes after the 3?
303.
So 303,000?
Yep.
And what comes after that?
1801.
1801? That's too many numbers.
1801.
You said, oh, it's not 3303, it's just, okay, so we have 3 million, so there's a 3 in front, right?
303.
And then it's 03, and then what comes after the 3?
18.
So 1, and then
801.
801, okay? 3,031,801 hairs after 4 months' time. Then 1,580 is the next one. So starting with 3,039,001 minus 60 times 1,580. How many hairs are left after that? Gabe? No. We're on 1,580. You skipped ahead. Emerson?
2,944,201.
2,944,201. And then after 50,650 days, so 3,039,001 minus 60 times 50,650. Gabe, how many hairs?
1.
1. And I've already planned ahead. I'm going to make that hair really, really long, so I can just like wrap it around the rest of my head and make it look like I have a full head of hair. But 50,000 days, there we go. Okay?
That means you have to live to 140.
Again, the hand raising would be fantastic. Lucas,
How many years is that many days?
figure it out.
I did.
Matthew did.
138.
Can't wait. Claire,
I think it's 110 years inaccurate.
what does that mean, Claire?
Oh, that's stupid.
What are you saying
She's
right now?
saying that she thinks you're gonna go bald in
Gabe.
20 years.
Which hair is it going to be? Do you know,
Huh?
do you know what hair is going to be the last
The
hair?
one in the middle.
Oh, I thought it was gonna be
Like
better.
equal coverage. Yeah. Yeah.
One
You
hair
live
in the
for
back.
138.762144424 years.
That's the plan. Okay. Any questions on this?
Okay.
Your homework for Monday, because tomorrow is going to be a retake day. Just my observation of last Friday, it was not very productive. There were people who were playing music, there were people who were playing games, doing all sorts of things. You know, when just like conferences can be made awkward if you're not doing the bell ringers and the homework checks, getting those free points, and your parents are like, wait, you can go back in. I'm telling them this tonight at back to school night. Like, you can go back in, you can fix it as many times as you need to. You go over answers in class. Like, how are they not getting 100% every single night? And I say, okay. Retake days are kind of the same thing. If you've got a lot of retakes to do from the entrance exam, and then at conferences, your parents sit down and say, well, why aren't they finished? And I say, I don't know. They've had 2 full in-class retake days to do them. Plus, I've been available after school. Then it makes it awkward for you. So don't let that happen. Get your practice work done. Make tomorrow a productive day, and go from there. Khan Academy. A number of you I know are having issues getting into Khan. I don't know why. I brought it up with IT, and we're kind of figuring things out. Maybe I have to go in a different way. I'm not quite sure. Anyway, Khan is not going to be due tonight. I'm extending it to next Thursday. So if you've already done it, then you're still getting credit for it, right? You've already have it done for next Thursday. If you haven't, then please be a little bit patient. We'll figure out the login situation, and then it'll be due to you next Thursday. So due date for Khan extended to next Thursday due to login issues. Claire.
Are you
Claire.
gonna post a new Khan Academy
No, nope, what I assigned last week, I'm just gonna push to next week till we get this login thing figured out. Rowan,
Will you sing Goosebumps by Travis Scott?
I will not.
Miles Brothers.
Lauren. No, that's me. I own this, okay? Homework for Monday then. These 8 questions, work must be shown, ops operations must be used. And then you've got a few 2-word problems down on the bottom. Questions, comments, concerns, complaints, comments, congratulations, criticisms on this. Gabe,
What is your favorite bond?
I don't know, I like them all. Matthew,
Congrats on living to 138.
haven't done it yet, but thanks. James,
My mom is a year older than you.
great. Fantastic news. Peyton,
Cool.
I forgot.
very well.
But no, I remember. For your birthday present, I was going to give you a giant ball of Parmesan cheese because we found it in the lunchroom in my spaghetti. But then William took his cup and he crushed it with my cup.
I wasn't
So I was carrying it in a cup and I was going to put it in one of your water bottles with the whatever else is in there. It was huge. It was like that big of a bottle.
Yeah.
Sadly, it didn't work.
Henry,
Congrats on being a nerd.
thank you very much. Nerds rule the world.
My dad.
Lucas,
I'm criticizing your opinion on yourself
why?
because you shouldn't call yourself smart.
No, nerds rule the world, man.
He
Yeah,
hates
no,
the
you,
nerd.
you would not have any of the technology that you hold near and dear to your heart without nerds. Nerds invented the computer, nerds invented cell phones, like, no, nerds rule the world, man. Nerds rule the world. Gabe,
Can you do me a favor?
sure?
Can you go to all the bunny?
No. Damien,
Would you rather move to Australia or New Zealand?
neither, Fiji. Last one, James.
What?
My uncle's a nerd too.
Good. We should be friends. Okay, with gusto, that's high math.
Don't forget to like and subscribe.